It's time for our last video in Chapter 4 about Simpsons Paradox. So, the local newspaper examined the town's 2 hospitals and found that over the last 6 months at Mercy, 79% of the patients survived, while at County, 90% of the patients survived. The following table summarizes the findings. So, let's think. Let's see, compute the marginal frequency distribution. We're using a useful technique of turning all the percentages into actual numbers for better comparison. Yes, this is a really useful technique. I agree. For example, 79% gets written as 790 out of a total of 1,000, right? And then that would mean 210 died. And then you change it to 1,000 over here, and that would mean 100 over here. All right, so you know what I'm going to do? You can feel it coming, right? I'm going to copy and paste. So I'm sorry, I misspoke on the last one. I didn't realize. So I changed the title on this because it said 4.4 examples. So I changed it to 4.4 examples 2 and 3. And then I'm going to go in here and make this 4.4 example 4. And this really is the last thing we'll be doing. Okay, so I'm going to paste here. I'm going to kind of make it bigger so you guys can see. All good. All right, I'm going to find the total equals sum of these two. I don't really have to do it that way, but I feel like it. All right, and then I'm going to do equals sum of these two. I'm going to click here and then drag over that formula drag thing we learned in, what was it, chapter 2 when we first learned that? Okay, I'm just making this pretty. All right, so now the next thing they want is compute a marginal frequency distribution. So we did that. It's right here. So I could copy and paste these numbers in. Everything would be great. The marginal part is literally in the margins. So let me paste. So when you do this, it's this guy right here, this column, and this row right here that create your margins. Okay, next they want us to compute the conditional distribution of mortality by hospital. So I'm going to go back to Excel. And remember, if it's by hospital, then you pick the hospital row and go across. If the hospital had been column, you would have gone down the column. All right, so let me go here. I'm going to kind of copy and paste a little bit. All right, so to find this, what I want is to compare Mercy just to Mercy. So I take 79 divided by 100, and I don't want the, or excuse me, 1,000. I don't want the 1,000 to change, so I give it $signs F4, and then I drag across, and then I do it again. Equals the 900 divided by the total F4, drag across. Boom. Okay. All right. So there we go. You can see lovely, lovely conditional distribution. So I'm going to go in here and paste it in. Done. All right, so based off of that conditional distribution that we made, which hospital do you prefer to go to and why? Well, I think that's pretty obvious. County hospital. Because it has higher survival rates. 90% compared to Mercy's 79%. So you're thinking, Alana, this is so basic. I mean, where's the problem? The problem is if you try to divvy up the data just a little bit finer. So this is, people always say, oh, lies, damn lies in statistics. This is how statistics lie to you. They're not lying. I mean, county hospital seems like the better hospital. But I'm going to tell you right now that it's not. And the deal is that, if you were a person in county hospital, you'd be like, we're better, we've got 90%. And the person at Mercy say, yeah, not so much. Let's look at the patients by class. So we have patients that are admitted in fair or better condition, and then we have the patients that are in poor condition or worse, okay? So I'm going to actually copy and paste this in just because I'm going to take the whole table. Copy, and of course if you can't copy and paste, then you're just stuck typing it. There we go. All right, so let's just look at the fair conditions or worse, okay? Now, how many total are there? Equals sum, total, and then I can drag that down. So I find the sum. Okay, so Mercy Hospital only had 590 admitted that were in fair condition or worse. See that? County Hospital has 890 admitted in fair condition or worse. Interesting, no? So what percent of Mercy Hospital people are living? Well, that would be 580 divided by the 590. And I can change that to a percent or leave it as a decimal. You get the drift. Okay? And I can do it again. It would be what percentage of county is living? 860 divided by 890. Isn't that interesting? And if you want them in percents, just highlight them. Go to Format, Cells. I'm going to turn them into percents. And one decimal place is all I need. Cool. Okay, catch that. Everybody catch that? 98% of Mercy patients live. Only 96.6% of county hospital patients survive. Amazing, isn't it? So Mercy does a little bit better, not by much, but a little bit better with the people that are in fair condition. But it gets a lot less of them. Now let's look at the remaining 1,000. So remember, there were 1,000 patients. 890 of them are in county at or fair. That means this is 110, which it is. But in case you don't believe me, we are going to copy the whole thing. Copy. There it is. Or you could copy this one that you already made and just put in the different numbers. That would work. Paste. Okay. So I'm going to find the sum equals sum. These two numbers. Boom. Now notice that makes 1,000, right? If you take 410 and 590 together, here, let me highlight them just so you can see them. Those two make 1,000, right? You got 1,000 patients total. They make that total of 1,000. Okay, 890, 110 make a total of another 1,000. That's where the other group comes from. Give them blue. Amazing blue. All right. So what percentage are living in this hospital? Let me see. I've got this formula. Let's see if it'll work. Look at that. So if they're admitted in poor condition or worse, so if they're in really dire straits, hey, look which hospital does better again. Mercy Hospital does. They managed to get it so that 51% of their poor condition people survive, and county only gets 36.4%. Are you catching this? You seeing what's happening? Because it's kind of amazing. Hold on. Let me go back. Okay. Oops. Hold on. There we go. Oh, God. There we go. Now I got it. Okay, so look. I'm going to make Mercy yellow, just so you can see. Okay? Both of those percentages are higher than counties. You see it? They did better with their poor patients. They did better with their good patients, their fair patients. Okay? So being admitted with a gunshot wound, you're far more likely to survive at Mercy. But even being admitted in good condition, you're far more likely to survive at Mercy. So we did all of that. Okay? So what's happening, right? Mercy is has better survival rates in both classes of patients, fair and poor, right? So the fair conditioned patients and the poor conditioned patients, Mercy does better with both of them, right? The problem is, it's not really a problem, but how to put this? So why did it seem on the previous page that Mercy was worse? Well, it's because Mercy gets 4 times as many poor condition patients as county. So look what's happening. County gets 890 fair condition patients. So naturally they're going to seem better because they're only getting the good patients, right? They don't get a lot of the bad really bad off patients, right? So they get to say, oh, we're doing so well, but that's because they're only getting the well patients to begin with. Mercy, on the other hand, gets a whole bunch of terrible patients in bad condition and does pretty well with them, right? Mercy gets 4 times as many poor condition patients as County. So the overall combined score makes it seem like Mercy is worse because, of course, poor condition patients don't survive as well because they're in poor condition to begin with. County only gets 110 poor condition patients, and it doesn't even do that well with the ones it gets, right? So then the question becomes, well, what have you seen with Simpsons Paradox? So 2 variables may appear to be related in a certain way, but when you reveal the third hidden variable, which in this case was like the condition of the patient, sort of like a lurking variable, if you will, then that apparent association disappears and even reverses in direction. So this is known as Simpsons Paradox and underscores the importance of the design of a statistical experiment, and particularly research behind lurking confounding variables. So in this case, let me put it this way. Condition of patient was a lurking variable. And I will said it before, but I'll say it again. This is why correlation does not mean causation. It seems like it's one way, but then you get this other variable in there, and it totally messes up the mix, right? So it's totally a lurking variable in the background. So Mercy is actually the better hospital for both fair and poor condition patients. So I'd go to Mercy. All right, now we are all done with Chapter 4. Now you may save and close and upload your Chapter 4 file. All right, and we are done with these lecture notes. I will see you back here for Chapter 5. We begin our probability journey. Chapters 5, 6, and 7, all probability. See you then.